In this video, we're diving into the world of data consistency patterns. We'll explore different consistency models crucial for understanding distributed systems. We will cover strong consistency, eventual consistency, and causal consistency. Let's define data consistency. Data consistency ensures that all nodes in a distributed system agree on the same data values at any given time. This is a challenge because of multiple replicas across different locations. The goal is to maintain data integrity and reliability. Let's take a look at strong consistency. In strong consistency, all reads receive the most recent write or an error. The system appears as if there's only one copy of data. Key features include immediate consistency, no stale data reads, higher latency, and lower availability. Let's look at an example of strong consistency using a banking system. In the function transfer money from account to account, an amount within a transaction, the balance is retrieved from the from account. If the balance is greater than or equal to the amount, the balance is updated on the from account, deducting the amount. The balance is then updated on the to account, adding the amount. Finally, a success message is returned. Otherwise, an insufficient funds message is returned. Financial transactions require immediate consistency to prevent double spending, inconsistent account balances, and audit trail violations. Every read must reflect the latest transaction state. Now let's examine eventual consistency. With eventual consistency, the system will become consistent over time, but temporary inconsistencies are acceptable. Key features include high availability, low latency, temporary inconsistency, and best effort convergence. Let's look at an example of eventual consistency using a social media feed. In the function publish post, the user ID and content are passed as arguments. A post is created with the user ID and content. Then, an asynchronous propagation to followers occurs. For each follower in the user's follower list, the post is asynchronously propagated to their feed. Finally, a post-published message is returned. Social feeds can tolerate temporary delays in updates. Posts appear gradually, different users see updates at different times, and high availability is more important than instant consistency. Eventually, all followers will see the post. Now let's discuss causal consistency. With causal consistency, operations that are causally related must be seen in the same order by all processes. Concurrent operations can be seen in different orders. Key features include preserving cause and effect relationships. It is better than eventual consistency but weaker than strong consistency. It provides a good performance balance. Let's explore causal consistency with a chat application. In the function send message, user, content, and an optional reply to are passed as arguments. The message includes the automatically generated ID, the user, the content, a vector clock for tracking causality, and the reply to information. The message is then broadcasted with causality maintained. Chat messages must maintain conversational order, such as question before answer, original message before reply, and thread context preserved. Concurrent messages can appear in any order, but causally related messages maintain sequence. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.